Hello everyone. So today we are here to discuss the concept of decoders. So firstly we will see the definition of decoder. So decoder is an multi-input and multi-output combination circuit which converts the coded inputs into the coded outputs. So in general we can say that it is also an example of combinational circuit which accepts multiple number of inputs and process them, and it will generate the multiple number of outputs depending on the logic involved in the particular circuit. Okay, so for a decoder, as the name indicates that generally it accepts n number of inputs and it will convert or it will generate their respective 2 power n number of outputs. Okay, so it accepts n number of input and it generates 2 power n number of outputs. And the operation, how it will become in sense, among these 2 power n outputs, only one output is selected for every input combination. Okay, so how can we say that is it accepts n number of input and generate 2 power n number of outputs, and among these outputs, for each and every input combination, one among 2 power n will be activated as 1 and the remaining will be taken as 0. So this is the operation behind the decoder. So as the name indicates that decoding, that means we will have a small number of or a minimum number of inputs at the input side and when compared to the outputs. Why? Because at the inputs we are having only n number inputs, but at output side these n are becoming into 2 power n, right? Suppose if you substitute n is equal to 2, you will have only 2 inputs and output side you will have 4. 2 has become as 4. Suppose if we have 3 inputs and 3 is becoming as 8. That's why you will have less number of inputs and you will have more number of outputs in the case of decoder. Okay, and its representation is given as n cross 2 power n. You can say it as n cross 2 power n, where n is inputs, 2 power n is outputs, or else you can say it as n is to 2 power n. N is to 2 power n, both are same. You can call it as n cross 2 power n or n is to 2 power n, both are same. Okay, now let us see the block diagram. See, this is the general structure. See, at the input side you are having n number of input data bits. You are having n number of, so we are having n number of data inputs here, and these n number of data bits are transmitted over this particular circuit, and this generates these n into 2 power n possible outputs. So these n data inputs are being converted into possible 2 power n outputs. But what is the specification here is, among these 2 power n outputs, one output or the first output according to the first combination will be activated and the remaining will be 0. Likewise, you can say that for every input combination, there exists one of the 2 power n outputs as activated state. Okay, so apart from these inputs and outputs, we have a special input called as enable inputs. So what is the purpose of this enable inputs? These enable, in the sense, these inputs make this particular circuit to be in active state or inactive state. In the sense, this particular input can make the circuit in off state or it can make circuit to on state. Okay, on and offing of the circuit is depending on these input called as enable inputs. Okay, suppose if enable is equal to 0, that means if enable is in deactivated state, these all outputs will not be generated. In the sense, this circuit will be in off state so that the outputs will not be generated. Okay, usually the decoder is provided with enable inputs in order to activate the output state at the data inputs. Okay, because of these enable inputs, one among the 2 power n will be activated. Suppose if this enable is not supplied, then you will get all zeros only. Why? Because no output will be generated because the circuit is in off state. Okay, so remember that if you want to make these particular outputs to be activated, the particular enable inputs should be in active state. See, when enable input is not activated, all the outputs of decoder are disabled. These will be in disabled state when enable is 0. If enable is 1, then respect outputs will be generated as it is. Okay, so be clear that enable inputs and these inputs, data inputs, are both are different. Don't combine these enable inputs in these. You should not count these inputs into this. Okay, these are separate, these are separate. These are the data inputs which are being sent into the decoder for processing, but these inputs are only used for the purpose of making the circuit to be in on state or to make the circuit to off state. If enable is equal to 1, then the circuit will be in on state and outputs will be taken. When enable is equal to 0, then circuit will be in off state and you cannot take any output because the circuit won't generate the output. Okay, this is the general structure of decoder. Suppose if you take n is equal to 2 here, then which decoder will be formed? For n equal to 2, 2 into 4 decoder will be formed. 2 into 4 decoder will be formed. So let us see what is 2 into 4 decoder, how the circuit will be operated in that. Okay, so this is the definition. You can note it down. The decoder is a combinatorial circuit which accepts n-bit binary input and one activated output of 2 power n. See here, one activated output out of 2 power n. What I said, among these 2 power n, only one will be activated for each combination. That I am mentioning here. One activated output out of 2 power n output codes is called a decoder. N inputs, 2 power n outputs, enable inputs. Okay. Now see here, we are having 2:4 decoder. 2:4 in the sense 2 inputs will be there and 4 outputs will be there. Okay, clear? So 2 inputs in the sense I took A comma B as my inputs. Okay, I took A comma B as my inputs. Input A, input B. First of all, the circuit should be on state for generating the output. So I took one more special input called as enable. I am not mixing this with the A comma B. That's why I put a line separator here. Okay, I am separating this special input. Okay, like this you can draw. You can draw the particular diagram, sorry, table, which differentiates enable input, normal input, and outputs. This is the enable input, which is only used for making the circuit to on or off. And these are the normal inputs, and these are your outputs. How many outputs you will have? 4 outputs you will have. 4 outputs. I took them as Y0, Y1, Y2, and Y3. Okay. Now let me clear this. Okay. Now, if you see here, when enable is equal to 0, so what can we say that the circuit will be in off state? Okay, why? Because it is 0, so it is in off state. So when it is in off state, the circuit won't generate any output. That's why the output column all is 0. See here, you won't get any output. All the outputs are 0. Why? Because the circuit is in off state. When you see inputs here, x comma x, what is x generally? Generally, we have seen the concept of don't care. Wherever you find x, either you can replace 0 or you can replace 1. That means, what does it mean in sense? Irrespective of input, whatever the input may be, the circuit won't bother about this. It bothers only enable input. If enable equal to 0, whatever the input may be, okay, whatever the input may be, the circuit, the output will be always 0. Okay, it won't, when enable equal to 0, it won't bother about input. The circuit won't bother about input. Whatever the input may be, the output must be 0. Why? Because it is in off state. That is the condition. Okay. Now, suppose if you want to take this particular case in case of x equal to 1, sorry, enable equal to 1. So what is enable equal to 1? Circuit will become on state. Enable equal to 1 means the circuit will become on state. Now we are having two inputs. Obviously we'll have four combinations: 0 0 combination, 0 1 combination, 1 0 combination, 1 1 combination. What I have said, for each and every combination, one among the four will be activated. One among the four will be activated. So see here, to just remove this case. Why? Because we have seen previously, this is the case when circuit is in off state. So no outputs will be generated. So leave this. Now you see this one. See when 0, 0 for the first input condition, first output y0 is activated and the remaining three are 0. And for second combination 0, 1, second output y1 is activated and the remaining three are 0. And for third input combination 1, 0, third output y2 is activated and the remaining three are taken 0. And for fourth output is activated and the remaining three are in 0 state. Okay, that means for each and every input combination, 1 among the 2 power n, that means 1 among these 4 will be taken as high, taken as your output, and the remaining 3 will be left alone. Okay, so this is the truth table of 2 to 4 decoder. And now you need to draw the logic diagram. So what is the equation of y0? In the entire column of y0, you find only a single one present here, and that one is also representing the 0 0 condition. So 0 0 in terms of AB means in SOP A bar B bar, A bar B bar. Likewise, what is the equation of y1? Equation of y1. In equation of y1, where you find 1, here you find 1. Only a single one present. That one is also representing 0, 1 state. So 0, 1 in terms of A, B is A bar B. A bar B. Okay, like that, if you write for y2, what you will get? This one related to third combination 1 0. So you write here as A B bar. I am writing the output expressions. Observe carefully. Next, what about y3? Here 1 is present, and this one is related to fourth combination 1 1. So you will write y3 as AB. Okay, y3 as AB. Now we have written our 4 output expressions. Now it is easy to draw the logic diagram. Okay, so first let me clear this. See, for the first y0, you have first take A, draw a line and pass this A through inverter, it will become as A bar, and take B and pass through the inverter like B bar. So you are having A bar, B bar, and you find a special input called as enable, which is this enable is linked, then only we will get these outputs. Remember that when enable is linked with this, then only we will get these outputs. So don't forget to link the enable input for each and every AND gate. Okay. So A bar, B bar means start from A bar, put a line, starting from B bar, put a line, and this is enable line. Total 3 inputs. Draw an AND gate, right here y0, like that y1, y2, and y3. Don't forget to link enable inputs commonly for each and every AND gate. Why? Because until unless enable is taken, you won't get these outputs. So this is the logic diagram. Okay. So when you say the same concept, or when you keep the same concept for some more higher order decoder, suppose if you take n equal to 3, then you will have 3 to 8 decoder. So same formula. First enable equal to 0 means irrespective of any inputs, output will be 0. The same format what we see in the previous. Next, for enable equal to 1 condition, then we will have different inputs. As we are having 3 inputs here, we will have 8 combinations: 0 0 0, 0 0 1, 010, 011, 100, 101, 110, 111. These are the 8 different combinations when we get when enable equal to 1 for 3 inputs. So for the first input combination, first output will be activated. For second input combination, second output will be activated. Third input combination, third one will be activated. Fourth input combination, fourth will be activated. For fifth input combination, fifth will be activated. Like that, for last eighth combination, eighth output Y7 is activated. Like that, you will get once in this format. Remember, for each and every combination, one among the 8 will be activated and the remaining will be 0. Okay, among 8, only one should be activated, the remaining 7 will be 0. Okay, now the same condition, you can write equations for y0, y1, y2, y3, y4, y5, y6, y7. Okay, and you can draw the same diagram like this. Take A bar, B bar, C bar, and put one common bit called as enable, common line for enable. What is the equation of y0? A bar, B bar, C bar. So draw a line from A bar, draw a line from B bar, draw a line from C bar, and apart from these three, you should add one enable so that it will be activated. So y0, y1, y2, y3 till y7. Total 3 inputs and 8 outputs. 3:8 decoder with enable input. Okay, very important. 2:4 and 3:8. Now there is a special decoder. So this is the IC number of 3-state decoder, the practical IC 74X138 that we are using in the designing of digital circuits. This IC represents the operation of 3-state decoder. It's very important, 74X138. Okay, then it is mandatory for us to know what is the pin configuration, how many inputs are there, and what kind of inputs are there that we need to see. As the name itself, it is indicating 74X138 is a 3-state decoder. So 3-state decoder means 3 inputs will be there. ABC. See the diagram here. 3 inputs will be there, and these 3 inputs will be in active high state. What is active high state? The input given directly to the circuit is called active high. The input which is given within bubble, see like this, bubbles, these are your active low states. Okay, any line which is linked with bubble is active low. Any line which is not linked with bubble, it is active high. So it accepts 3 binary inputs, and when enabled provides 8 individual active low outputs. Remember this, for 74X138 decoder, the 8 outputs present y0 from y7 are active low condition. Okay, are active low condition. See here, we are finding bubbles, which means that all the 8 outputs starting from y0 to y7, all these 8 outputs are active low. These 3 inputs are active high. Why? Because we don't find any bubbles here. These are active high. Apart from these 3 inputs and 8 outputs, we have 3 more enable inputs. 3 enable inputs. Among these, 2 are active low. Okay, among this, 2 are active low. 2 are active low, that is G2A bar, G2B bar, and 1 is active high, that is G1. Okay, these 2 are active low, G2A bar, G2B bar, and this is active high. So this is very important. Okay, this configuration, IC configuration is very important. 3 active high inputs, 8 active low outputs, 3 enable inputs, among which 2 are active low and 1 is active high. Okay, now we will see what is the cascading of decoders. So what is meant by cascading means, suppose if I need 4 is to 16 decoder. I need 4 into 16 decoder, but I don't have this decoder with me. I am having only 3-stage decoder. Then it is necessary for us to know how to improvise or how to enhance this 3 to 8 decoder into 4 into 16. Okay, cascading means taking a small size decoder and improving this order. That means designing of a big decoder with a small decoders. Cascading in the sense a series connection. Okay, series connection of the circuits. Okay, so how to see this? So how to see this is nothing but, so if you clearly see this, so first of all, let's take an example. So with an example, if you analyze, then it is clear for us. Okay, so let us see a question. So see here question is explained with the 4 into 16 decoder using 74138. So what is the 74138? Already we discussed it previously. It is an 3 into 8 decoder. It is an 3 into 8 decoder. So what the question is, by using 3 into 8 decoder, they are asking us to design 4 into 16. Okay. So first of all, you need to know how many 3 to 8 decoders are required. How many 3 to 8 decoders are required for us to designing an 4 into 16. To design 4 into 16. So 4 into 16 decoder means obviously you should have 16 outputs. Here we are having 8. If you take one more 3 into 8, then this 8 and this 8, when you add these two, then you will get 16 outputs. Adding means tying up, cascading. Cascading means tying up the inputs. Okay, so we can adjust these 6 outputs. Here you are having 6, right? So you can adjust these 6 outputs. Okay, so let us see how to cascade that. Okay, so see carefully. So when you see this diagram, this is the first decoder, this is the first decoder, and this is second decoder. Okay, first decoder and second decoder. I am taking two separate 74138. See 74138, here 74138. I am taking two different circuits. So here I am having 8, here I am having 8. So total I am having here 8 and here 8. If I want to add these, then definitely I should tie up the inputs. Okay, so see here I am having 3 inputs ABC. Okay, here I am having 3 inputs ABC, and here also I am having 3 inputs ABC. So as the inputs are common here, I am tying these inputs here. See, the dots represents means the tying up of inputs. Okay, I am cascading them. Okay, so therefore I will take common inputs A, B, and C for first IC as well as second IC. The common inputs are taken. So whenever I have made this cascading, obviously these 8 and these 8 will become a group. So that why not to y7, here you are having 8, and here why not to y7 is having 8. So 8 plus 8 you will get 16. Okay, when these two will become as a group, when you made this cascading. Okay, until unless you group like this, until unless you tie like this, these two groups of 8. Okay, until unless you do this cascading, these 8 and these 8 won't be add up. If you want to add this, definitely you should tie in this format, cascade. When this cascading is done, obviously this 8 will be added to this 8, and then you will get 16 outputs at a time. Okay, so by taking this cascading concept, we got this 16 at a time. So right now 4 into 16 we need, right? We need 4 into 16 decoder. So 16 outputs are framed. Now we should concentrate on this 4 inputs. Okay. See, 3 inputs are there here, A, B, C, that we have done previously. And when you observe carefully, we are having 3 enable inputs and here 3 enable inputs. You can select any one from these 3. You can select any from these 3, tie them and make it as 4th input. I need one more input extra. That's why I selected this G2A. I selected this G1 and made this as a 4th necessary input called as D. And I selected G2B. I selected G2A and I tied up and I make it as enable. Right? Without enable, circuit won't operate. That's why I tied up these two and make it as common input called enable. After doing that, this one will be remained empty and this one will be remained empty. So this is given with a resistor and 5 volts is supplied here. As I am having voltage supply, obviously I should have ground. That's why I kept ground here. So if you see clearly, we were having 4 inputs A, B, C, D and one enable for on and off of circuit and 16 outputs at this side. So this will be treated as 4 into 16 decoder. If you clearly observe, this entire circuit will be acting as 4 inputs, 16 outputs, and one enable input for on and off of the circuit. How it is looking like? 4 into 16. So I need 2 3 into 8 decoders for designing one 4 into 16 decoder. And this is the process how to design. So this process of tying up the inputs, see the black dots, this process of tying up the inputs is called as the cascading, or you can call this as an expanding of circuits. Okay, next. Next, we need to know how to represent the Boolean functions or the output functions by using the decoder. So this is the one more concept that we are having. Okay, so see here, you can realize the switching functions. Generally, switching functions can be realized in 2 different methods. One is SOP implementation and one is POS implementation. And now here we are having 2 different cases, like suppose if your decoder consists of active high outputs. Suppose if your decoder consists of active high outputs, then how to implement the decoder? Suppose if you are having active low outputs, then how to implement the decoder? That is the normal condition we need to implement. Okay, so please make a note of these points. Suppose if your decoder consists of active high inputs, suppose if your decoder consists of active high inputs, and if your SOP equation is implemented, and if you want to implement an SOP equation, you should use NOR gate. You should use OR gate. Okay, the points you should note down is under active high output, when SOP equation is to be implemented, OR gate to be used. Under same high output condition, if POS is want to implemented, NOR gate is selected. And what is second case? When active low output, that means your decoder is treating with active low output. If SOP is want to be implemented, NAND gate is chosen for us. And POS means AND gate. Okay, please remember these points. Okay, active high output means SOP means OR, POS means NOR. Active low output means SOP means NAND, POS means AND. If these 4 points are remembered, then you can realize any expression with the help of decoder. Okay, the help of decoder. Okay, let us see with an examples now. See, this is the first example. What is given here? Implement the function summation m. What is summation m? SOP. Summation m is SOP. By using 3-state decoder, act under which condition? Active high condition. So under active high condition, if you want to implement the summation m, so active high condition SOP. So what is the condition you are using here? Active high condition SOP means which gate you need to use. We can verify the previous slide. So active high condition SOP means, see, active high condition SOP means OR gate to be used. OR gate to be used. So this is the circuit. First of all, you should draw one gate. So if you see here, so the given function is an SOP function, right? Summation m, and the given condition is active high. So obviously you should take OR gate for representing. So first you draw the asked decoder. What is 3-stage decoder with 3 inputs ABC and 8 outputs Y0 to Y7? And you should be careful while drawing this diagram. Active high condition, so you should not add any bubbles here. Directly you draw lines like this. Active high means no bubbles will be there. Active low means bubbles should be added, but in the given question it is active high, so directly draw the lines like this. Now you take one enable like this, and now you see the given numbers 1 2 3 7. So collect the first output y1, second output y2, next third output y3, and seventh output y7. So these are your output numbers 1 2 3 7. So y1, y2, y3, y7, all the four should be connected to OR gate. Why OR gate means, as per the condition of active high condition, SOP should be linked with OR gate. So connect like it is an F. Simple, very simple. The framing of diagram is only important. The given asked decode is 3 to 8. So take 3 inputs, 8 outputs. And these 8 outputs you should mention here under active high condition. So always the output should be high. So take directly 8 lines like this and connect the asked given numbers 1, 2, 3, 7. So y1, y2, y3, y7. These should be linked with, okay, linked with one OR gate. Okay, next. Let's see the next question. See here. Here pi capital M is there. That means it is an POS form. So active low condition POS means which gate you need to use. That we will verify. See here. Active low condition POS means AND gate you should be used. You should use AND gate. So just use. See here. You draw the 3-stage decoder. 3 inputs will be there and 8 outputs y0 to y7. And what is the question given? Active low condition. That's why I am adding bubbles. You should add bubbles for each and every output line. Okay, why? Because these are all active low outputs. That's it. What are the given numbers? 1 3 5 7. So y1, y3, y5, y7, all these to be linked with AND gate as per the condition. As per the condition, you should link with this AND gate, and this AND gate will represent capital F. This is the given expression. Okay, the same format. You should remember the point is whether the given condition is active low or active high. Active low means directly draw the lines. Active high means directly draw the lines. Active low means add bubbles in the line. And as per the given condition, you connect them with always particular gate. Okay, so we take 3 inputs here, and as per the given question, these are active low conditions. So take the low outputs and connect the given numbers to AND gate. Okay, now if you see the question, this is the question regarding two expressions given in the same question. That is one SOP question and one is POS question. And didn't give an active high and active low, but they have given a hint that it is using 74x138. 74x138 already we have discussed that this decoder will consist of always active low outputs. Okay, this decoder will consist of always active low outputs. That means the given question is coming under active low output condition. Okay, as the 74x138 decoder consists of active low outputs by default, the question will be comes under active low output condition. So active low output SOP means NAND gate, POS means AND gate. So directly draw the 74x138. See, 3 inputs will be there 8 outputs will be there. That too, all the 8 outputs will be in active low form, means complements will be there, and 1257 should be linked with the NAND gate. Why? Because it is an SOP equation. And 034 should be linked with the, sorry, just a second. So here the question is little mistake here. You just replace 2367. Okay, here you replace 2367. 2367. So these given numbers are linked with the AND gate. AND gate means POS, NAND gate means SOP. Okay, you just change the question like this. So whatever they may be, suppose if this is number, directly take 0, 3 as well as 4 and connect to one NAND gate. No problem. Just the remaining is these numbers should be linked with the NAND gate, and whatever the numbers present inside the POS concept should be linked with the AND gate. That is the concept. Okay, whatever the numbers may be. Okay, so just I am saying about this one. Take these two as your questions so that this will be a diagram. Okay, so by this the concept of decoder is completed. So what are the points you need to remember is, okay, first of all you need to know what is the definition of decoder. Okay, what is the definition of decoder, and then you need to note down what is the operation behind a normal decoder. So by taking example of 2 into 4 as well as 3 into 8, and then you need to know what is the cascading of the decoders, and you should know how to realize the functions using decoders. Okay, if you see that or if you learn them carefully, then it is easy to understand the next coming method or next coming example like encoders. Okay, so we will meet in the next video with a new topic called as encoder. I hope the session is understand to you. So if any doubts you can ask me. Otherwise you can post in the comment section. Okay, so by this the concept of decoder is completed. Have a nice day and thank you.